Okay, good morning again. This is Professor David J. De Los Reyes. Okay, my topic for this morning will be a long video format discussion on alternating current circuit, and we are now on lesson number 9. Okay, this is a long video format discussion. The topic is alternating current circuit for those who will be taking up electrical engineering, or you are on the verge of taking up electrical engineering. This is for you guys. Okay, let's proceed. Topic for this morning will be alternating current circuit, lesson number 9. The title of the topic will be the discussion on power factor. Power factor is actually one of the most important circuit parameter if you are having a business and you are consuming electricity coming from the utility companies. Okay, because with this power factor, if your power factor is unity, okay, I will tell you now, your utility companies love you very much because you are helping them with the current consumption that goes to the public. Okay, you are helping them. But if your power factor is lagging, okay, they might hit you a little bit. If your power factor is leading, oh, they might love you, okay, because it's leading. You are helping the system, right? But for lagging power factor, you are not helping the system, okay? For leading, you are helping the system. But if your power factor is unity, you could make it unity by using the so-called gadget of Mr. Elon Musk, the one that's using power factor correction. It is actually a small gadget in which that gadget will try to fight out that lagging current, because that gadget will bring out a leading current which will fight out that lagging current, so your power factor will become unity, right? This power triangle, this portion here will begin under unity. So your total consumption is just S. Sorry, this one. This should be R. Oh, no. This is P and this is Q. Okay? If Q is 0, your power consumption will be P because S will be equal to P under unity. Okay, let's proceed with the formulas and how to bring out force before we will go towards this discussion. Okay, the formulas for computing power factor. Okay, this is very important. Okay, so for those engineers who are maintaining the power consumption of a certain company, okay, these are the ones they are using and how to bring out power factor. Okay, so they know for a fact the current is coming in. They know that that current will be the minimum current that will help the utility companies. Okay, you do not try to overload the utility companies by having a lagging load. Lagging load meaning mostly some of your loads or 80% of your loads are actually motors. Of course, if you are an industrial company, mostly your 80% of your load will be motor load. So whether we like it or not, your power factor will be lagging. Not unless you will do something to correct it, okay? You will be consuming so much power in which the utility companies might not like it. Okay, let's proceed with the formula and how to bring out power factor. There are actually 4 formulas. PF here, sorry for this one. PF is power factor. Okay? PF is power factor. There are 4 formulas. Power factor, this is the most, what you call this, the ones they're always using. In layman's language, they're doing this. But for those who are taking up electrical engineering, we don't only use this one, we got to use also the other 3. We know also the other 3, but the most relevant they're using is actually the first equation, this power factor. is the ratio of the true power over apparent power. Okay? True power over apparent power. True power, this is the one we used to pay on the utility companies. And apparent power, we are not paying for this one. For this apparent power, we are taking in current, and which some of the current is not helping the utility companies. So we try to minimize this one if possible by bringing out a pure resistance load for the company so that the power factor will become unity. So no more power triangle, it is just simply a straight line. Okay? So formula number 1, it will be the ratio of true power over apparent power. True power, this is the one coming out from the meter, right? For this apparent power, okay, you just multiply the voltage of the utility company times your total current consumption. Okay? If you try to multiply the utility voltage multiplied by your total current consumption, total, okay? So this should be a very big one. If it is a smaller company, it could be kVA maybe. But if you are a multi-million company, maybe your consumption is MVA. Million volt ampere. So million volt ampere, okay? If the volts is small, for it to be million, the current should be big. Okay, that's large. That's why it is million volt ampere. Okay, that's formula number 1. The other formulas we are using under electrical engineering is the cosine of theta sub c. Meaning, theta sub c is the angle of the impedance. If we try to bring out the impedance triangle, assuming an inductive load, this is XL, this is R, this is impedance, that theta z is actually this one. Okay? If you take the cosine of this angle, okay, between the impedance and the resistance, that is still considered power factor. Or in relevance or in connection with this cosine of theta z, another formula on how to take power factor will be the ratio R over C. Okay, because the cosine of this angle is adjacent over hypotenuse. So if you take the ratio resistance over impedance, that is still power factor. Right? So actually, this formula number 3 emanates from formula number 2, because if we try to take the cosine of this angle, that is power factor, but since from the study of trigonometry, cosine is actually opposite, adjacent over hypotenuse, so cosine of theta z is actually the ratio R over C. So that's formula number 3. But if for the meantime, you are not given R and Z, and you are given only theta z, you could compute now for the power factor by using the cosine of, taking the cosine of that and multiplied by 100%, that will be power factor. The last one, okay, power factor can also be written as the cosine of the quantity theta sub E minus theta sub I, where theta sub E is actually the angle of the applied voltage, the angle of the voltage coming from the utility line. And theta sub I, this should be with the subscript I, guys. Theta sub I will be the angle of I, the angle of the current. Okay? This is I, the one current going into the load of the company, right? The total load of the company, compressed load will be Z, right? So if you try to get power from the utility companies, you connect your lines to the utility companies, and the applied voltage is E. And this E here should have a value maybe 120 volts, angle 0 degree. So this 0 degree here is actually this theta E, right? And for the current, okay, there should be a current with the value ampere, also angle theta. there should be an angle theta for this one. Okay? So this is with the subscript I. So this will be I equal to, there is a certain ampere and there is a certain angle theta I that will come out. So the difference between this, the angle of the voltage and the current, the difference, take the cosine of that, it will still be the power factor. Okay? How we illustrate this one, it is something like this. This is the vector diagram of the voltage coming from the utility line and the total current drawn by the company from the utility line. If this is the applied voltage, this should be the current for a lagging load. But if the current is leading, it should be something like this. Or lagging is downward, right? This should be leading. Okay? It is something like this. If the current is leading, this is the angle, right? This is I, this is E. If the current is lagging, this is E, and this should be I. This should be minus theta I, theta. This is plus theta. And if the current is a pure resistance, this is E. Sorry for this one. This is E. And this is I. Okay? Leading load, lagging load, pure resistance. So the angle between the voltage and current, if you take the cosine, that will be power factor. For a leading, the angle between the voltage and the current, which is negative, you take the cosine, that will still be power factor. And for a pure resistance load, if the angle of the voltage, okay, and current are the same, cosine of 0 is actually 1. That's why it is unity. The power factor under a pure resistance load, the power factor is actually 1. It's 100%. It is 100. It seems it is just like an efficiency. So if the utility companies know that your power factor is unity or 100%, you might get a credit from your, what you call this, balance from the utility company. But if your what you call this power factor is lagging, they might punish you. If your power factor is leading, they will love you. But for pure resistance load, they will love you more. Okay, that's it, guys. How we compute power factor under alternating current circuit. So for those of you guys who are taking up electrical and engineering, this is for you guys. If you want to subscribe to my channel is at youtube.com/@prof.david.j.de.los-reyes. If you want to share it, please click share. Okay, try to watch my long video format. I am discussing concepts over here and I am giving example problems on how to illustrate those concepts. Okay, good morning from Los Angeles. Professor David J. De Los Reyes.